Alright guys, hope you had seen a few examples of how recursion works. This is yet another mathematical function or mathematical sequence, I would say, which can be easily computed using recursion. So this is what we call as the Fibonacci sequence. Let me give you some explanations in comments before I start off with the coding. So we are going to see what is called the Fibonacci sequence. I guess you guys are familiar with it. Still, let me give you a very brief overview. So the Fibonacci sequence starts with 0 and 1. This is the 0th Fibonacci sequence. Same like computers, here the counting starts from 0. 0th Fibonacci sequence is 0th Fibonacci number is 0. Let me write one by one, that's better. 0th Fibonacci number is 0. Sorry, it's 0. Sorry, I'm sorry for this. 0th Fibonacci number is 0. The first Fibonacci number is 1. Second Fibonacci number is nothing but, now you have got two numbers. Let me put it, okay. So given that you got two numbers, you add these two numbers and you got the result as 0 plus 1 is 1. So this is your second Fibonacci number. The third Fibonacci number is nothing but, add the last two, 1 plus 1, 2. 2 is your answer. The fourth Fibonacci number is 1 plus 2, 3. 3 is your answer. The fifth Fibonacci number is 3 plus 2, 5. This is your answer. And so on. And it keeps going. It keeps on going. This is an infinite sequence basically. The initial two values are nothing but the seed values they had given. These are the, in our recursion terminology, this is the base case or the anchor case. This is the base case or the anchor case. For these two things, we know the value, we can directly return the value. We can directly say this is the value. If they say I want the first Fibonacci number, you can directly say first Fibonacci number is 1. If someone is asking you the 10th Fibonacci number, something like that, you don't know. You need to calculate it. So using 0 and 1, you find 2. Using 1 and 2, you find 3. Using 2 and 3, you find 4. So do you see? A bigger value of the Fibonacci number, that is the nth Fibonacci number, depends on the value of n minus 1th Fibonacci number plus n minus 2th Fibonacci number. So it depends on the previous two values, right? So here we can apply recursion and we can easily find the nth Fibonacci number. So our objective here is to find the nth Fibonacci number. Fibonacci number. We can have an iterative version of the code too, but in this case I would leave the iterative version of Fibonacci number as an exercise for you guys. Please do try it. It is not very easy, it requires some amount of thinking, but it's not Herculean task or something like. It's not rocket science. It is doable. So you need to invest some amount of time, you invest some amount of thinking. If you do that, you can find the iterative way how to find the Fibonacci numbers. So that I would leave it as an exercise. I would demonstrate the recursive way for you guys. Okay. So let us start off. I need to define Fibonacci. I would say Fibonacci of n. Nth Fibonacci number is what I want to find. I know the 0th Fibonacci number and first Fibonacci number. 0th number is 0. First number is 1. So in this case, I need to return. If the given n is 0, I need to return 0. If the given n is 1, I need to return 1. So if n is 0 or 1, I need to return back the n itself. So that is my base case. Okay. So that is why I had given a space here as well. This is the base case, and maybe I'll put a dash here. This is the base case, and these are derived from the base numbers. Okay. So this is the base case. So let me first put it. If n is less than 2, and similar to that, for negative value of n, Fibonacci is not defined. We need to check that in the main part where we are calling this functionality. Same like factorial, how it is defined just for positive numbers and 0 and positive numbers. Fibonacci is also defined only from 0. For negative numbers, it is not defined. So let me say 0 and 1, right? So let me say if n is less than 2, just return back that n. If it is 0, return 0. If it is 1, return 1. So return back that n. Okay. Else, if it is greater than or equal to 2, from 2 onwards, we are dependent on the previous values. So you should return back the Fibonacci of n minus 1 plus Fibonacci of n minus 2. Maybe you want the second Fibonacci number. You should return Fibonacci of 2 minus 1. That is Fibonacci of 1 plus Fibonacci of 0. That is how we calculated. Fibonacci of 1 is 1. Fibonacci of 0 is 0. That is the first Fibonacci number is 1. 0th Fibonacci number is 0. So 0 plus 1, we got 1. That is how we had calculated, right? So that is what we are doing. You take the previous two Fibonacci numbers and add it, is what we are doing. If you need the third one, what you do is second plus first. First one you know the value, so substitute 1. Second Fibonacci number you don't know, so you calculate second Fibonacci number plus 1. For getting second Fibonacci number, again you call it. For second it is first plus 0th. So 0 plus 1 is 1. 1 plus 1 is 2. So you will get the third Fibonacci number. So you can trace it on a paper and you will understand the working. So this is how basically Fibonacci numbers work. If it is less than 2, just return back the same value. Otherwise, return back the sum of previous two values. Right? This is the intuitive way of explaining Fibonacci numbers. See, we have translated our intuition. We have translated the intuition into code very easily. All thanks to Recursion. With this powerful technique, we can really make this code very easier. But for iterative version, you can write an iterative version. I don't say that with iteration it is totally impossible. You can write an iterative version, but it requires some amount of thinking to be invested here. Okay. So I have got the answer. So I should take an input. N is equal to an integer input is what I wanted. So I'll typecast because of my machine dependency. I'll typecast input, enter a positive, maybe I can say a non-negative, that is better because 0 is also defined, right? So I should say non. Even in factorial, please make the correction there. It is non-negative because 0 factorial is 1 is also defined. So enter a non-negative number. Enter a non-negative number is the input, is the message I got, and some input I will get. Still I need to check in case the person has by mistake entered a negative number. I shouldn't throw at him some results that is incorrect. So I should throw him, I should tell him the suitable message properly. So I will print undefined for negative numbers. N is less than 0, meaning that it is a negative number. Whatever input he has given, what is undefined? Fibonacci numbers is undefined for negative numbers. Okay, so I will say Fibonacci numbers are undefined for negative numbers. Okay, so I had given it Fibonacci numbers are undefined for negative numbers. Else, if it is not a negative number, then I should print the nth Fibonacci. Nth is not correct because if he gives first, second, I have to put ST and D appropriately, so that formatting is needed. I would modify the message instead smartly. Fibonacci number at position, sorry, it is position, sorry for this, position n is, I should call Fibonacci of n. Alright, I hope you guys can understand this till now. See, I take a number, input a non-negative number, 0 or positive, I agree. If it is a negative number, I say it is not, it is undefined. I print this message. Else, I call this functionality Fibonacci on n. Okay, so if I call this functionality Fibonacci on n, if that number is less than 2, for 0th Fibonacci number is 0, first Fibonacci number is 1. This is something defined as the base case for us. So in that case, I will return the value of n. Otherwise, I will compute the sum of previous two Fibonacci numbers, right? So this will input the nth Fibonacci number. So for first, let me verify. For that, let me enter 5. If I enter 5, I should get 5 as the answer, or maybe if I enter 4, I should get 3 as my answer. Let me verify it first, then maybe I will find the other Fibonacci numbers. Okay, let me run the file. Okay, enter a non-negative number. I will enter, so just for verification, I enter -7. Fibonacci numbers are undefined for negative numbers. Yeah, I got the proper message. Okay, now let me test it. If I enter 4, the fourth Fibonacci number is 3. I should get 3 as my answer. Let me run it. Enter a non-negative number. Let me enter 3. Sorry, 4. Fourth Fibonacci number is 3. Third Fibonacci number is 2. Fine, you can do it. Let me enter 4. Fibonacci number at position 4 is 3. Yeah, it is working. So now let me find out the 10th Fibonacci number. Let me do 10th Fibonacci number. Fibonacci number at position 10 is 55. Maybe you can list the numbers like this and you can verify. But it's correct. So once it's working here, definitely it will work for any value. So using this program, you can find the Fibonacci number at the nth position in the sequence. In the Fibonacci sequence, what is the number present at the nth position? So here nth is nothing. Luckily, this is one thing in mathematics which is very close to computer science. Counting starts from 0. So nth number is nothing but, for humans counting style, n plus 1th number. Please have that in mind. Here counting starts from 0. I would recommend that you guys invest some time thinking if you can do this in an iterative fashion. It requires some amount of thinking to make it iterative, but it is possible. It can be done, but it is not straightforward. It requires some amount of thinking. So when you invest some time for thinking in the iterative style, you would definitely appreciate the technique of Recursion, because it lets you do something straight away from your intuition. Whatever you understand from someone's explanation, you can straight away translate it into a code. Recursion allows that thing. That particular thing is difficult when you do it in the iterative way. But still, it's not a rocket science, it's doable. Please do invest some amount of time. Try doing the iterative version. And please do discuss in the discussion forum of how you tried the iterative version, what are the challenges you faced, or if you can print the sequence, Fibonacci sequence. If they are asking the nth Fibonacci number, can you print the sequence starting from 0 up till the nth Fibonacci number? Can you try that variation? You can do a lot of things. Please do explore and keep trying more examples so that you understand how recursion actually works. Thanks for watching. Have a nice day.